I wanna be the very best, like no one ever was. To catch them is my real test, to train them is my cause. I will travel across the land, searching far and wide. Each Pokemon to understand the power that's inside.
Mr. Poseidon!
All right, guys. So today I'm not here for the lesson, so we are actually starting a new unit. Our new unit is rate, ratio, and percent. So looking at our units here, we are at unit 8, rate, ratio, and percent. So if you want to pause the video for a second here, and you can split up your dividers and start a new section in your binder. With the title rates, ratio, and percent. And at the top of a new page, we have lesson 1 speed, rate and speed. Okay, so we'll get right to it. Remember, guys, you know the drill. So pause at any time if I'm going too fast or you need to copy something down. If you have any questions when I get back, we'll talk about them. But please do your best to try to follow along, and we'll get going. So starting off here. So rate and speed are two things that come together. A rate is basically how fast something occurs or how slow something occurs. Okay, we talk about flow rate in science, so it's how fast a fluid passes a certain point. A speed is a type of rate. Okay, a speed is specifically the amount of distance covered over a certain period of time. Okay, a rate is how fast something is moving similarly, okay, or it's how fast you're completing a task. Okay, so to start, when we're calculating rate and speed, this is where we'll start. We have to be able to complete two actions. We write down the rate we're given, establish a unit rate that is asked in the question, and equate the two and solve for the unknown. So we're coming back to our equation solving, or solving for an unknown variable, just like last unit. Okay, so we're going to use all those skills that we've been learning. Okay, so what I mean by that is that an example of write down the rate that you're given. So say that I'm able to read, say, 10 pages in 30 minutes. Okay, my rate for that is 10 over 30. Okay, so this was A. B is establish a unit rate that's asked in the question. So I might want to say, well, how many pages am I reading per minute? Okay, notice that on the top we wrote our pages, on the bottom we wrote our time. Okay, so if I want to find out how many pages I'm reading every minute, okay, I'm given this value down here as 1 minute, and this is what I want to find up here. And our last step says to equate the two. So we would have 10 over 30 is equal to x over 1. Okay, so what we're going to do is we're basically just going to solve. Okay, and we'll do this with an example down below. So starting with this one down here. Example, if a typist can type 250 words in 5 minutes, how many words can they type in 1 minute? So part A, write down the rate you're given. 250 words in 5 minutes. Okay, so I'm just going to put a little side note here. Okay, write down or write your rate as a fraction. Okay, it makes it so much easier later on when you're trying to equate the two and solve for the unknown. How many words can they type in 1 minute? So the second part of the question, how many words can they type in 1 minute? So B, in our steps, okay, we want to find out how many words we can go in 1 minute. So we have, I don't know how many words here, and it takes us 1 minute to do it. So part C says for us to equate the two. So C is going to look like this. 250 over 5 is equal to x over 1. Okay, and I just choose x just because it's an unknown, it's a variable, it's something that we're going to find, and it's something that we're all used to. Okay, so typists can type 250 words in 5 minutes. How many can they type in 1 minute? So now we're just going to solve for x. So this is just a regular equation, a regular statement that we've seen already before. So what we want to do is we look at everything that's being done to x and we want to undo it. Okay, so this one's really easy. Okay, it's x over 1. We're dividing by 1. We're going to multiply by 1 on this side, and we're going to multiply by 1 on this side. The 1's cancel out. Okay, and we're just left with 250 over 5. So this is a really straightforward one that we don't have to do too much work for. So 250 over 5 equals x. Okay, and just before we run out of space, I'll just move it up here if you want to keep your equal signs going downwards. Okay, so 250 divided by 5 ends up being 50. So I'll rewrite it up here. 250 over 5 equals x. 50 equals x. So with any of these word problems that we have, we're always going to write a therefore statement. So therefore, the typist can type 50 words every minute. Okay, and that's it. That's probably one of the easiest questions that you can ever get. There might be times where they might give you the amount of words that they can type in a certain number of minutes, and you might have a variable that's down here. When we run into that situation, we're going to bring the variable up top here, okay, and bring this down here. So we'll see those ones as we move along here. Okay, all right, so moving on, part 2. Sometimes we might be given information, that requires us to first change the type of units or asks us for an answer not in the units given. So this example is a perfect display of that. So starting off, if 36 kilograms of insecticide is required to dress a field of an area of 3,000 meters squared, calculate the rate in grams per meter squared. You notice right away that 36 kilograms is not the same as grams. Okay, so we go back to our conversion lessons that we've had before, and 36 kilograms is equal to 36,000 grams. Okay, so 36,000 grams. So what this question is asking us, okay, we're just going to follow the same steps, is how many grams per meter squared. Okay, so this one's going to be x grams per meter squared. And the ratio that we're given, okay, we're going to take our 36,000 and we have our 3,000 up here, 3,000 meters squared. Okay, and part C of our steps say that we're going to equate the two. So we have 36,000 divided by 3,000 equals x over 1 for 1 meter squared, for every meter squared. Okay, that's what the question's asking. So, same thing, easy as the question before us. Okay, to get rid of that 1, multiply by 1. The only reason I do this is just in case you run into a question where this isn't 1, say it's a 7, you'd have to multiply by 7 on this side and 7 on this side to get rid of it. So we would multiply by 1 to cross them out and multiply by 1 on this side. It really doesn't change anything over here, so all we're really doing is 36,000 divided by 3,000. Okay, so our answer ends up being 12. Okay, so for part A, therefore, okay, the rate of dressing the field is 12 grams per every meter squared. So this question is just asking us how much insecticide are we going to use for every portion of the field. Okay, and that's also known as a rate as well. So that was A. We're going to look at B this time. So B in kilograms per meter squared. It's already in kilograms, already in meters squared, so we don't have to change anything. So we'll start B up here. We have 36 kilograms per 3,000 meters squared. Okay, we want to find out how many kilograms are used per every meter squared, for every 1 meter squared. So same thing again, 36 divided by 3,000. Okay, and it's going to be a little bit of a different number, so we'll just grab a calculator here. It's going to be a smaller decimal, so we'll go 36 divided by 3,000 is 0.012. So we have 0.012 equals x. So for this question, we say therefore it takes 0.012 kilograms per every meter squared to dress the field with insecticide. Okay, now the point that I want to bring up here is that these are two completely different looking numbers. Although they represent the same thing, they both represent the same rate. One is in kilograms per meter squared and one is in grams. Okay, so sometimes it makes more sense to change units to give the reader a better perspective. Better perspective. Okay, and that's why I had to just do it in grams per meter squared and kilograms per meter squared. Okay, so we have two questions so far. Okay, finding out a unit rate. Okay, how fast can they do something in 1 minute? And then finding out a rate in sort of a different fashion, but basically just looking at how much is used per a certain area. Okay, that's also a rate. We're going to go down to our last one. A final example might require us to do a little bit more work. Okay, so final example might require us to calculate our answers in steps. The best way to do this is set up a table and analyze where we can fill in the blanks, which scenario has the most information. Okay, so if you look up here at each one of these ratios, you notice that you have 3 pieces of information out of the 4. 1, 2, 3, and you're missing 1. Up here at the very top, you have 1, 2, 3, and you're missing 1. So that's what we're going to be looking for when we're given this information. There's a lot that's happening here. Okay, we'll read through it first. A motorist took 2.5 hours to travel from town X to town Y. His average speed for the whole journey was 80 kilometers an hour. For the first quarter of the journey, he traveled at an average speed of 60 kilometers an hour. Find his average speed for the second part of the journey. So this one is split up into different rates. Different sections. So when we have this, what I want you guys to do is I want you to try to get used to setting up a table that represents each part or each section. Okay, so over here, we're going to have journey. Okay, and we have first quarter of the journey. Okay, last 3 quarters, or which is the total. Okay, which makes up the total. And then it says the motorist took 2.5 hours to complete the travel from town X to town Y. So all together, so we're going to have a section that has total trip. Okay, so what we're doing is we're going to eventually create a chart here. So in the journey, so you can say distance. It's one of the units we're working with. Time. And the last one is speed. Okay, so I'm just going to draw in a couple lines here to help us distinguish between each section of this chart. Okay, dividing it up into each part of the journey and the units that we're using. Okay, so the distance. Let's see what we can fill in here. Motorist took 2.5 hours to travel from town X to town Y. So his total trip took 2.5 hours. His average speed for the whole journey was 80 kilometers an hour. So his speed here was 80 kilometers an hour. For the first quarter of the journey, he traveled at an average speed of 60 kilometers. So in the first quarter, he went 60 kilometers an hour. Okay, find his average speed for the second part of the journey. Okay, so in this section here, we have, we look at which section gives us the most information. And right now, under total trip, it gives us the most information. So I'm going to write this in green, something different. 2.5 hours going 80 kilometers an hour. So you're setting up your ratio like you did before. Over here, we have 80 kilometers, 1 hour. Okay, and on this side, we're going to set up our 2.5 hours, or 2.5. Okay, but we don't know how many kilometers we've gone. Okay, and that's what we want to try to find out. So to do that, we're going to be solving for x, which means whatever's being done to x, we're going to do the opposite. Or any operations that we see happening over here, we're going to do the opposite. So if we're dividing by 2.5, we're going to multiply by 2.5. So we have x over 2.5. We're going to multiply to get rid of that. That decimal stays. Okay, equals 80 over 1 times 2.5. Okay, so these 2.5s cancel out. We're left with x equals 80 times 2, which is 160, and a 0.5, which is 40. So 160, another 40 is 200. So 200 kilometers. Okay, so this x comes from up here, x kilometers, 200 kilometers. So we could put 200 kilometers in here. Okay, and you ask yourself now, well, I don't have any information up here or any information here. How am I going to find the first quarter, the third quarter, the time for each one? Okay, and this is going to take a little bit of your own intuition. So if you think for a second that you've gone 200 kilometers, okay, if you split that up into quarters, okay, to 4 equal parts, you'd find out how much a quarter of the trip was, or 2 quarters, or 3 quarters by multiplying that value by 2 or 3 or whatever you're looking for. So 200 divided by 4, okay, gives us 50. So right there, we have 50 kilometers. Okay, now you can multiply that value by 3, or you can just say, hey, if we go a total of 200 kilometers, and in the first quarter we've gone 50, how much should we be going in the second? We should be going 150 kilometers. Okay, so let's keep going. So you're gradually just filling out pieces of the information or pieces of the chart as you go along, and eventually you're hoping that it leads you down to here. And that's going to happen when you get a value for time under the last 3 quarters, because that's what it's asking you, the speed for the second part of the journey. Okay, so at this point, why don't we look at the time taken, okay, for the first part of the journey. So the time taken, we'll set up our ratio again, 60 kilometers in 1 hour equals, and we're going to put our distance in here as well. We've gone 50 kilometers in X hours. Okay, and this is an interesting one too, because X is on the bottom. And if you remember from last unit, our answer requires us to get X on top. Okay, so to do that, we would be multiplying by X on either side. And that leaves us with these X's being crossed out and 50 on this side. We have 60X over 1. Okay, or we don't even have to put that 1 in there because we know that 60 divided by 1 is just 60. So we have one last step. We have to get the X by itself. So we're going to divide this side by 60. And we're going to divide this side by 60. Okay, everything's in hours. So remember, our answer is going to end up in hours. So we have these 60s cancel out. I'm just going to move this up here. Okay, and 50 divided by 60, which is going to give us a decimal of 0.833 equals 0.833 hours is equal to X. Okay, now 0.833 of an hour doesn't really tell us much. It doesn't really give us a very good timestamp or a very good perspective of how many minutes it is. So a little trick here is you take this decimal. If you have a decimal of an hour and you multiply it by 60, okay, 60 minutes in an hour, your answer will come out to how many minutes there are. So it's saying 83 or 83% or 0.8333 of 60 minutes will give us, or of that hour will give us 50. Okay, so that first little bit, we'll put this down here, or 50 minutes. That first little bit took 50 minutes. Not sure where that top bit went. There it is. Took 50 minutes to give us another little, a better understanding of how many minutes this would be then. So 2.5 hours would be 60 minutes plus 60 minutes, so 120 minutes plus another 30 minutes gives us 150 minutes. Okay, so this here ends up taking us to be 100 minutes. Okay, but we're looking at kilometers in an hour, so we have to change that. We have to change that into hours. Okay, this part here, so this 100, so 100 minutes is equal to X hours. Okay, the conversion for this 100 minutes, you divide by 60. 60 minutes being in an hour divided by 60 equals 100 divided by 60 equals 1.67 equals 1.67 hours. Okay, we can put that up here as well, 1.67 hours. Okay, and now we have two pieces of information and we can find the third. Okay, so the last little bit, I'll do it in another color. We'll do orange this time. So last 3/4. Okay, we have a ratio of 150 kilometers over 1.67 hours. And what we want to find out is how many kilometers in 1 hour they're going. Okay, so to do that, again, we do our little thing with the 1, multiply by 1, multiply by 1, the 1's cancel out. Really don't have to do anything with it, to be honest with you. And we just do 150 divided by 1.67. So we're going to go 150 divided by 1.67. And it gives us 89.8 kilometers an hour. So 89.8 kilometers an hour equals X. Now, I'm going to fill that in here. And what I want you guys to think about, 0.8 kilometers an hour, is does that really make sense? Okay, total trip on average, you were going 80 kilometers an hour. For a first little bit, you're going 60, but for the majority of it, you're going 89. You'd have to think that to average that out for 3/4 of the trip going that speed would sort of bring that average speed up to 80. So I think that looks appropriate for a little, just a quick little check. And I want you guys to think about that too. Does your answer make sense? Does it fit in the way it should logically? Okay. All right. So that's the end of the first one. So that's rate and speed, coming up with the unit rates, using speed as a rate, and then looking at how you're going to approach different types of questions. So what you guys are going to be working on right now is 174, 175, and I'm going to set up another video for you. So for lesson 2. Okay, so good luck, guys. We'll talk when I get back.